Alright guys, so today I'm going to take us through solving a system of two linear equations, and then I'm also going to graph them on the Cartesian coordinate plane. Okay, so here are our system of linear equations, pretty straightforward. I have the line y is equal to negative x plus 8, and I have the line y is equal to x minus 4. So first we're going to solve this algebraically. The way we go about that is I'm going to use the system of elimination. So what I'm going to do is I'm going to either add or subtract or manipulate the equations in such a way that I can get one of the variables to cancel. I notice that equation number 1 has a negative x in it, and equation number 2 has a positive x. So I know therefore that if I just simply add these equations together, that those x's will cancel. So I'm going to do that right now. So adding the equations together, I get y plus y is 2y. I have equals negative x plus x is 0x. And 8 plus negative 4 is 8 negative 4, that's plus 4. And so I'm left with the equation 2y is equal to 4, and therefore it follows, dividing both sides by 2, I get 4 over 2, and therefore I find that y is equal to 2. Okay, in order to find my x value, I'm going to substitute in my y value back into one of my original equations. Doesn't matter which one. Let's take equation number 1 here. And so equation number 1 becomes, instead of y, I have 2. 2 is equal to negative x plus 8. Solving for x, I will add x to both sides, and I will subtract 2 to the right hand side. And so I will get x is equal to, I have an 8 on the right hand side, and I subtract 2. 8 minus 2, that's 6. And so I have that x is equal to 6. And so the solution to this system of equations is therefore 6, 2. 6, 2. All right, let's now go ahead and graph both of these equations on our Cartesian coordinate plane. So we know that this here is our x-axis, and this is our y-axis. This is positive y, this is negative y, and this is positive x. And of course that would be negative x in that direction. All right, so let's plot equation number 1 first. Well, I see that conveniently it's already in what we call slope-intercept form. Both of these equations are in fact both in slope-intercept form. The slope of equation number 1, well, the slope is the coefficient that is on my x terms. The coefficient on my x term is negative 1. I have negative x, so it's a negative 1 coefficient. So I have a slope of negative 1. My y-intercept is plus 8. So this plus 8 here is my y-intercept. So this here, this is plus 8. That's my y-intercept. I have a slope of negative 1. So that means negative slope is that direction. Negative 1 means I'm going to come down 1 and over 1. So down 1, over 1. That's a slope of negative 1. And so let me just roughly draw this line. That would be something like so. If you're using graph paper or graphing utility, you can be a lot more accurate. Here I have the line y is equal to x minus 4. And so now I also want to graph this on the same Cartesian coordinate plane. I'm also in slope-intercept form. The coefficient on my x term is 1, 1x. And so I know that the slope of this line is 1. I have a y-intercept of negative 4. So negative 4 is right here. Negative 1, negative 2, negative 3, negative 4 is right there. And I have a slope of plus 1. So I'm going to ballpark plus 1. And so that's about there or so. And so this is my second line. And so those are my two lines. This here is equation number 1, and this here is equation number 2. Those two linear equations. And this point here at which they intersect is this value right here that we found. This is 6, comma, 2. As you can see, it's pretty close to 6, comma, 2, even with my sort of rough graph. So this 6, 2, again, represents the value of x and y that satisfies both of these equations, both of these lines. In other words, geometrically, we would say that that is the point of intersection of those two lines. And so that is the relationship between the algebraic and the geometric for linear equations. All right, thank you.